好，接下来呢，我们要探讨的这个议题呢，是有关于 C-V2X Test Standard and Systems Introduction。这位呢是 Sales and Marketing Manager of ZoXTech， 他的名字呢是 Fangze Mr. 涂先生。来 VCR。
Hello, dear audience. This is Fangze, Sales and Marketing Manager from ZoXTech. It's my honor to be invited by MIH to talk about C-V2X test standard and system. Sorry I cannot be there on site today. If you have any questions, please ask in the Q&A session. And also feel free to email me if you have further questions. First, allow me to introduce my company, ZoXTech. We are MIH test partner, and we focus on the research and development of ADAS and V2X test solutions. Most of our team are based in Shanghai, and our core team comes from Chinese Academy of Science and NI. The image below are some of our previous work. We have provided field and laboratory testing solutions to different OEMs and test institutes. Let's look at different scenarios for autonomous driving. We all know there are different levels of autonomous driving from level 0 to level 5. Different companies have different strategies to achieve autonomous driving. Despite different strategies, sensors are always a very important part in addition to computing and control. In the right figure, we can see two different systems. In the upper one, the autonomous systems only use onboard sensors like millimeter wave radar, LiDAR, ultrasonic radar, and camera. Those sensors can only be used to detect objects and other vehicles within the visible range. In the below figure, we can see a better system we define as cooperative system. In addition to the onboard sensors, V2X are also included in the system. Vehicle can communicate with other vehicles and the infrastructure to enable detection of objects and events outside of the visible range. This is the key advantage of V2X. V2X are deployed in different regions globally. In North America and Europe, they deployed DSRC in several years ago and allocated frequency band to C-V2X in recent years. In China, they only apply C-V2X and not deploy DSRC in present and in future. In global standard, we can see in 5 layers, there is two major standards, DSRC and C-V2X. DSRC is created by IEEE organization earlier, and C-V2X is created by 3GPP later. But nowadays, more and more countries adopt C-V2X instead of DSRC because its technology is more mature. There is also different chip vendors like Qualcomm, Samsung, Autox, and HiSilicon can provide 5-layer chips. Because people in different regions have different driving habits and different regions have different driving scenarios, so there are different organizations in different regions to define the upper layer. In Europe, it's ITS G5. In the United States, it's WAVE, and in China, it's CSAE. When we look into the C-V2X access layer, there are two major interfaces are defined in 3GPP Release 14. The first interface is UU interface. It is very similar to our mobile communication. Vehicles need to communicate by base station. Another interface is PC5 or direct communicate. In PC5 mode 3, the signaling message is transmitted by the base station and the data message can be transmitted directly from vehicle to vehicle without base station. In PC5 mode 4, both signaling message and data message can be transmitted directly from vehicle to vehicle. In state-of-art systems, most popular system is PC5 mode 4. Because in technical side, it has less latency compared with UU interface and is also simpler in business side. In the future iteration like 5G V2X, we can see UU interface will also be included. It can enable more long-range applications. For PC5 direct communication active security scenario, we can see a lot of common daily life driving scenarios like blind spot warning, left-turn access. In those scenarios, the remote vehicle is outside of the visible range. So the low latency communication is very important to ensure the active security. In the C-V2X industrial timetable from 2019 to 2021 is defined as lead-in period, and from 2021 to 2025 is defined as development period. For vehicle terminal, we can see in recent years, a lot of the OEMs are launching new front-mounted C-V2X OBU. And a very positive forecast in year 2025, 50% of the new cars will be front-mounted of C-V2X OBU. For roadside, in recent years, most of the RSU are deployed in the demonstration area. It will gradually expand the coverage to typical cities and highways. In year of 2025, major cities and major regions will have the full coverage of RSU in major roads. For communication device, we believe before 2023, we estimate most of the OBU will be LTE-V, and after 2023, there will be more and more 5G V2X. For the test certification, last year we completed the C-V2X testing and the certification standards and begin to improve related testing tools and the testing systems. So let us look into the V2X test. Like OSI 7 layers, we define the V2X protocol as application layer, security layer, network layer, access layer, and file layer. There's also different test methods. For file layer, we mainly test the RF link performance of our OBU or RSU, defined as RF conformance test. Above file layer is access layer. In access layer, we test the communication quality, like throughput or communication latency. Above the communication layer, usually those layers are different from region to region, as we discussed in previous slide. Conformance test will be adopted for network layer, security layer, and message layer. And in application layer, scenario-based V2X testing will be applied. And also, we discussed with different customers. In OEM, they were more interested in the upper layer test, like scenario test, V2X based. And like in Tier 1, they are more interested in like RF conformance test or communication quality test. Talking about the RF test standard, 3GPP 36.521 define the transmit and receive measurement items. 3PPTS 27.007 define the AT commander that are used for the DUT control. For transmitter test, the instrument will be defined as reference receiver to test the RF transmit performance of DUT. Those test items such as transmitter power, EVM will be included. For the receiver side, it's vice versa. The instrument will be defined as reference transmit to test. For communication quality test, it mainly focuses on the access layer of LTV. The test methodology like high-traffic multi-vehicle simulation, precise timing and message playback will be applied. And test items such as packet loss rate, throughput rate, communication latency, and bit error rate will be included. About the access layer, as we discussed in previous slides, those layers are different from region to region. The CCSA is defined the network layer, message layer, and the security protocol conformance test in China. And the test items are basic interaction test, ability test, and behavior test. In the very top of the system is application layer. In this layer, usually will be different V2X usage cases. And some is common globally, and some is based on different regions' driving scenario. CSAE defined the two phases of V2X usage. In phase 1 or day 1 scenario, those cases are mainly focused on safety efficiency. 16 cases in day 1 are warning cases, like FCW warning. And the last is smart car payment case. In phase 2 or day 2, those cases are mainly focused on traffic management service. In the case of dynamic line management, 2 or more vehicles should cooperate with each other. To realize those tests we presented in previous, this is the V2X test architecture. In the bottom is device under test DUT, OBU or RSU. And above the DUT, there is 3 main test instruments: LTV emulator to emulate the remote vehicles or RSU to communicate with DUT. In the middle is GNSS emulator to emulate the GNSS signal for location and time information. The last instruments are I/O interface. Based on different DUT, we can provide digital, analog, CAN, Ethernet, and other interface. Above the 3 instruments, there will be 2D or 3D scenario simulation software, like MonoDrive from NI and others. The top of the architecture will be automatic test software management, like TestStand, to fulfill the automatic test, or VeriStand to fulfill the sensor fusion with other sensors, like radar, LiDAR, and the others we discussed. This is the real hardware for scenario-based V2X test. Online hardware like USRP can be implemented as LTV emulator to transmit and receive LTV message, and VST can be implemented as GNSS emulator to transmit main car position, time information, time and frequency synchronization. And different PXI cards in the PXI chassis can receive the CAN Ethernet signal from that for main car status or warning feedback. And also, OmniAir is the leading industry association to promote interoperability and certification for ITS and connect vehicles. NI test chain has been certificated by OmniAir for different layers and for different regions. As we discussed, V2X will be an important sensor in addition to traditional sensor system. Thus, from test point of view, the test system should be also open and scalable with other systems. At NI, we based all our test system on the PXI platform, which is an open standard modular architecture based on standard interface. The single one system can provide different modules like camera, LiDAR, V2X, radar, GNSS test, and also we can provide the different ECU test system like braking ECU, ADAS ECU, and engine ECU. This is the picture we define as the sensor fusion hill test systems. Using a vehicle radar simulator, the camera injection, the V2X simulator, and also the GNSS simulator, they will have different sensing signals to the real data. And also those real data is connected to the ADAS ECU. In conclusion, if we want to design a V2X test solution, the solution should be highly scalable, and the API interface can be open from bottom to the top. The same system can realize performance simulation, indoor and outdoor testing, and also the system should be based on the software-defined radio platform. It can realize both OBU and ICU simulation at the same time. The single one platform should also emulate more vehicles, like 100, and it should be support smoothly software upgrade to 5G V2X. And also, because we talk about there is different test method, so the test architecture and the platform design should be clear. From scenario to protocol, and then finally a communication. And thank you for attending my session. If you have any questions, please ask. And also feel free to email me if you have further questions. So I'm happy to discuss with you for any test questions in both V2X and the ADAS.